This video is on solving linear systems algebraically. In addition to solving a system of linear equations by graphing, they can also be solved algebraically. Two methods are substitution and elimination. Substitution works best when one of the variables in the system has a coefficient of 1. Let's take a look at this first example. This says solve this system using substitution. And I have the system of equations 2x plus y equals 3 and 4x plus 4y equals 8. Notice that the coefficient of y in the first equation is 1. So I'm going to go ahead and solve that equation for y by subtracting 2x on each side, which gives me y equals negative 2x plus 3. And since this value right here is what y is equal to, I'm going to substitute that into the second equation for y. So that's going to give me 4x plus 4 times what y is equal to, negative 2x plus 3, and that is equal to 8. So I took the first equation, solved it for y, and then whatever y was equal to, I substituted that into the second equation. Now I have one equation that has only x's in it, so I'm going to go ahead and solve that for x. And combining my like terms and subtracting 12 on the other side, I get that x is equal to 1. So there's 1/2 of my answer. Now I need to figure out what y is equal to. So I'm going to take this value of 1 for x and plug it into any of the equations I have over here, but I actually kind of like this one, which is solved for y. So y equals negative 2x plus 3. Whoops. Let's put 1 in there for x. Y equals negative 2 times 1 plus 3, or y is equal to negative 2 plus 3, or y is equal to 1. So the solution for this system is the ordered pair 1, 1. And to check that, I can plug in a 1 for an x and a 1 for a y and make sure that that works in both of these equations. So 2 times 1 is 2, plus 1 is 3. 4 times 1 is 4, plus 4 times 1 is 4. 4 plus 4 is 8. So that does indeed work. Elimination involves multiplying one or both of the equations by a constant so that when the equations are added together, one of the variables is eliminated. This is really helpful when you can notice that perhaps one of the coefficients is a factor of the corresponding coefficient in the other equation. So here's the system we have. 2x plus 5y equals 11, 2x plus 3y equals 1. Looking at my coefficients of x, I notice that if I can multiply this by a 2, I get a 4 here. So what I'm looking for is either the same or preferably opposite coefficients of the same variable. So if I were to take this whole equation and multiply it by a negative 2, I can see that that's going to give me a negative 4x, and when that's added to this 4x, they cancel each other out because negative 4x plus a positive 4x is 0, and I will be eliminating x from my system of equations. So let's go ahead and do that. So that's going to give me a negative 4x minus 10y equals negative 22, and I distributed that negative 2 3 times. And let's copy our second equation right underneath. And now I'm going to add these two equations because when I add my x is eliminated. So negative 7y equals negative 21, so y is equal to 3. And I can take that and plug that into any of my equations there. I think maybe I'll put it into the first equation for y. So 2x plus 5 times 3 equals 11, or 2x plus 15 equals 11. Subtracting 15 on both sides gives me 2x equals negative 4, and x equals a negative 2, which gives me the ordered pair negative 2, 3. And I can check by plugging that in. So plugging in negative 2 is going to give me a negative 4 plus 15 gives me 11. Negative 2 is going to give me a negative 8 plus 9 is 1. So indeed it does check. So here are a couple systems of equations that I would like you to try on your own. So stop the video, copy this into your math journal, and give them a try. Okay, so let's take a look at this first system. X minus y equals -8 and 7x plus 5y equals 16. I notice that the coefficient of y here is a -1, so I think I'm going to take that equation and I'm going to solve it for y. So -y equals -x minus 8, and dividing by a -1 gives me y equals x plus 8. So I'm going to take that and plug that value into the second equation for y. And that's going to give me 7x plus 5 times what y equals, x plus 8, equals 16. And let's go ahead and solve that. 7x plus 5x plus 40 equals 16, or 12x equals, subtracting 40 on both sides, is going to give me a -24. So x is equal to -2. And I'm going to take that value and plug it into this equation. So y equals -2 plus 8, or y is equal to 6. And now I can write my solution as an ordered pair, -2, 6. My second system of equations, 3x plus 4y equals 29 and 6x plus 5y equals 43, looks like it's well suited to elimination, because I'm noticing that my 3x and my 6x, if I can multiply this by a -2, then when I add them, that's going to turn into a -6x. Then when I add them, it will eliminate my x's. So I'm going to go ahead and multiply this whole first equation by a -2, and that's going to give me a -6x minus 8y equals a -58. And then let's copy our original first equation here, second equation, I'm sorry, and let's add those two. And notice when I add, my x's are eliminated, and that leaves me with 3y equals a -15. So y is equal to 5. And I'll take that and plug it into either equation. I'll just go ahead and do the second one here. And that gives me 6x plus 5 times y, which is 5, equals 43. Or 6x plus 25 equals 43. And subtracting, that gives me 18. So x is equal to 3. And that gives me my solution of the ordered pair 3, 5. So in this video, we took a look at two different methods for solving linear systems algebraically, by substitution and by elimination. Substitution works best when the coefficient of one of your variables is 1 or a -1, and elimination works well if you can notice that one coefficient of one variable is a factor of another.